In this presentation we'll have a look at an introduction to pen testing, penetration testing, and we'll concentrate on looking at Nmap and HPing and how they could be used in a pen testing scenario. Okay, so we'll cover a basic introduction to pen testing, then we'll look at port scanning, SYN flood, and spoofed addresses. When it comes to ethical hacking, then we typically define a white hat as being somebody who's good, a black hat as someone who has malicious intent to an organization, and a grey hat is someone who might be good at one time and then bad at another time. We can have other terms that are used. We have a cracker who are motivated by financial gains and have a criminal intent. Script kiddies, typically who don't have a great deal of skills to create their own tools, so they're running standard scripting tools. Software crackers will reverse engineer software to get the code back or break the licensing for programs. Freakers hack telephone systems. A hacktivist has a political agenda, and a whacker focuses on wireless LANs and WANs. Okay, so we'll have a look at how a white hat can actually use pen testing tools to be able to assess any weaknesses on the system. Okay, so it's first the important thing about pen testing is we need to understand what each of the terms actually mean. So risk is a likelihood of an occurrence of something that could do damage or cause a loss. A threat is something that could do damage, loss or harm. An asset is something that the organization owns. Vulnerability is a weakness in the system, and an exploit is an entity which takes advantage of a weakness in a system. So with this in mind, these are the key elements that we would use to be able to create our pen testing strategy. So we often have an evaluator, and with an evaluator we have a whole bunch of tools. Nmap we've seen, and we'll look at HPing, but we also have tools such as Nessus. These are well-known scripting tools. So scripting tools can only give you some of the key answer some of the key objectives of a pen testing. The other part is really the intellect of the pen tester to be able to exploit weaknesses that might not be obvious. So when a pen tester looks at an environment, there is a target of evaluation. This could be within a sandboxed environment, within a virtual environment, or it could even be that it's a pen test on a real live working system. The objective of the pen tester is to really look for exploits and then possibly look to see if they are vulnerable. So a white box test normally involves testing a system where the tester actually knows everything about the target evaluation. Grey box involves only partial knowledge, so there is much more discovery of the whole of the infrastructure that's been tested, such as for the services and so on. A black box test involves having no knowledge at all of the system, so there is much more looking around and finding out about what's going on. So some of the things that might be tested are Snort itself, firewall rules, servers, even users, and so on. It is important that the tester has a code of ethics, and a good code of ethics is that they will never exceed their authorization limits. They will always be ethical in everything they're actually doing. They limit the possible damage onto the system, and at all times they maintain confidentiality. If a tester was to find some data which might be sensitive, then that data should be kept to themselves. Normally, the tester will go through 3 main levels when the testing is happening. Level 1 normally involves high-level testing, and there's no need for a hands-on. It's typically having a look around, maybe looking at documentation, looking at the website, searching around for information which is in an open source environment. After this, we move to level 2, which normally involves network evaluation, scanning, doing vulnerability scans, and so on, finding out about the whole of the infrastructure. And then in the third level, we go to an adversarial role, and it is this phase that the tester will actually probe any of the weaknesses to discover any vulnerabilities. So some of the things that might happen is social engineering, contacting staff in the organisation, asking them for the passwords, their logins, asking for sensitive information, stolen equipment attack, so the tester could actually steal equipment, a physical attack into the system, an outsider attack, or even an insider attack. So there are many different levels of testing. Normally at each stage we get approval to move to the next stage. And within this we typically focus on CIA, and CIA will actually look at the confidentiality infrastructure, integrity infrastructure, and the availability infrastructure. So for the confidentiality, it's really only authorized entities are allowed to access sensitive information. So for this we have firewalls and passwords and encryption and VPN access and so on, even locked doors and armed guards. For integrity, we have our Windows file protection, checksums, network operating systems, and that's to make sure that data is only changed by those entities who are actually authorized to do it. Any changes not by entities who are not authorized should be logged. And then availability really looks at having continual access to data, and that's very much looking at mirror servers and failover equipment, UPS, and so on. Okay, so with CIA in mind, that's how we would define our objectives for the target of evaluation. Okay, so why do we do our pen testing? Well, sometimes it's to do with an audit compliance regime, and we need to make sure that our systems are actually operating correctly. So we have things like Sarbanes-Oxley's, which relates to the accounting and reporting of companies in the US. We have HIPAA in the US for healthcare, and so on. So there's a whole lot of acts which cover the reasons why organizations must keep their data sensitive and protected. So often we would go through written permission from the organization. We would then scope it with them, perform the assessment, and then we'd have some post-assessment activities. Could be a workshop or a presentation or so on, outlining any vulnerabilities identified. So let's look at a few different methods that a tester might use to be able to discover services and hosts and so on a network. Port scan is a pretty standard method that's actually used, and we've seen up to now that we can scan over the hosts on the network. Another typical method that's used is a port sweep, where we are interested in a certain port and we'll sweep across a range of hosts. Okay, so we'll do that. So nmap, and we're interested in port 80 on our network, and we're only interested on 192.168.47 network. And just to prove what is happening here, let's open up Wireshark and capture our traffic on our virtual network. Okay. This -P option. So what nmap is actually doing is actually discovering if the machines are actually on first. Okay, because it does no good to go and sweep if the machine isn't actually on. Okay, so you can see it's got a response back here. So then what it'll do is it'll actually go to the machine, and there's another couple of nodes on the network. It will go and actually find the machines that are on, So there you go, it's sending out on 254. 254 is one of the hosts that it's discovered. Here. It also sends a SYN on port 80 to 132 and also 132 here. And here we're getting a return back SYNAC from 132. So let's have a look at 132 to see what the basic stream is. Okay, so Nmap is sending it a SYN, getting a SYNAC, and then Nmap is saying we'll just reset the connection. Okay, so in this way we can actually sweep across the network using the -P option with Nmap. Okay, so you can actually see here is the here's the machines, only interested in port 80. Okay, so when we do a general Nmap on a machine, then we actually see a whole lot of ports being scanned. Some of the main methods that could be used for the scanning, we can do a TCP scan. TCP scan will do the full SYN, SYNAC, ACK, FINAC, or reset. And the SYN will just send in a SYN flood of half-open connections. That can cause problems on a network because the server may have to keep open all the connections and it may overrun its memory. And then we can send in a FIN. With a FIN, the closed ports will typically respond back with a reset, but open ports will actually ignore. The FIN can actually get over a firewall that in a way that possibly a SYN will not. Okay, so the full range of scans that we actually have, we have a connect and a SYN. So this is our connect is ST, SYN is -SS. And then we have a whole lot of other ones, FIN, null, Christmas tree, scan, and acknowledge. With a FIN, we used to send FINs onto the server. Null has no flags at all. A Christmas tree is FIN, urgent, and push, and an ACK is just an ACK, and that's often used to determine the ACLs in a firewall. And what we should get back is on a closed port we get a reset, and an open port it just ignores it for a Christmas tree scan, and FIN and null and acknowledge. Okay, so let's give that a try. So what we'll do is we'll do a Christmas tree scan and we'll see what we get back. So what we want is, here is our server. Yeah. And we just run Wireshark. And we capture on our interfaces here and here. So in this case we don't want to scan the whole of the network, we'll just scan our virtual server with the Christmas tree. Okay, so there's the ARP going out. And there we go. So the one thing to see is that this is what the Nmap is sending out to the server, FIN, push, and urgent, and here are the replies coming back. So anytime we can actually examine a flag. So we can just show the packets that have got reset in them. And then we can show reset and ACK. Okay, so these are the replies, and you can actually see, that our reset ACK is coming back from our closed ports. So in this way we've knocked on the port and it's actually given us a reset back again with our fin push and urgent. We can obviously order in terms of what's coming back from the source. Okay, so it's given us these things back. Okay, so we can do a fin scan. Let's just open up Wireshark again. Now it's already running. Okay, so there's our fin scan coming through, and you can see here that it's discovered these ports are open purely with a fin scan. Okay, so there's all the fins that are going in, and then these are all the replies that are coming back from a reset, and Nmap is able to discover which ports are actually open depending on what it actually sends back from the fin scan. Okay, so these are a few different examples of the types of scans that we actually get. UDP scan is -SU, and so on. Another tool that we can use and we need to be very careful about is hping, and hping allows us to be able to graph our data packets. Okay, so the standard format that we have looks a bit like this. We've got to run it as a super user. This does a SYN flood on a certain port. So what we see is that we should see a SYN, and here we see that the destination port in this case is port 0. So by default, hping will default to our port 0 destination unless we actually specify it. So let's actually do that right now. And so you'll see that I've specified, so just to be sure, we're on Ethernet 3. So if you want, you can use TCP dump on interface Ethernet 3. It's just an alternative way for us to be able to view the data packets. But we'll also run Wireshark just to show what this looks like. Okay, so we'll just bring up another terminal. So we'll do a SYN flood for 43.1. And there we go. So you can see there is the .0 for SYN. And we can see the SYN coming in for port port 0 on random ports. You can also specify the port number. So if we want to evaluate on port 80, so we can now see that port 80 is the target for our packets. Okay, so in this way we can actually evaluate how the target evaluation can cope with some sort of stream. So this could be used as a denial of service evaluation tool if we had enough of these agents actually streaming, and then they can send in hping. So we really need to be very careful about how we use hping, and it should be really just focused with inside a private or a sandboxed environment. Okay, so we can also, as we said, define on port 80. Okay, so the SYN flood is often used to evaluate a server to be able to see if it can cope with a denial of service type attack. Okay, and so with that we often see a flood of these SYNs coming in. So if we look at the, if we use nmap, or if we use our hping again, so this nmap and hping allow us to be able to create these streams on a certain port to be able to evaluate if the server can actually cope with the data. So that is focused on port 80 on this server. And with the denial of service, what we have is we have a distributed denial of service. We have multiple streams that can actually bring down the server. And what we need to understand is how we need to set our infrastructure up to be able to possibly detect a denial of service, or at least cope with it. Normally what happens is that we actually define the hosts that are actually attacking us, and then we would actually create a firewall rule to actually disable any sort of connection from them. So it would detect the SYN connection across the router, the firewall in this case, and then that would actually be blocked from actually getting to the end device. One thing that a tester or an intruder could use is spoofed IP addresses, which will mean that it's very difficult to actually determine the source of the traffic. So again, if we have a look at our Linux machine here, and we find that the option for this spoof address is a -a. And in this case the packets will be crafted with a source address of 10.0.0.1. Okay, so we can see here, up here, that there is 10.0.0.1 is used for the source address of the data packets. And let's start this. that we can actually see what that looks like. And there we go. So we can see here 10.0.0.1 is the source address. In this case we're not changing the MAC address at all, but you can see the source packets actually have a spoofed address. We can do the same with inside Nmap. So we can see here there's the spoof IP address. So this presentation is really just giving an overview of some of the methods that we might use with Nmap and hping.